Okay, so today we are going to start with the concept of thermal expansion. And this is the easy section, easy topic in this chapter, because you know that we already discussed about when we provide thermal energy to any body. So it starts to expand. And we already know about that the gaseous state or in the gas molecules will expand more freely as compared to the solid and liquid because of weak intermolecular forces between them. So we have to discuss about thermal expansion. So in simple words, you know that when you try to heat up any material, so normally that material starts to expand. And in terms of molecules, you can say that molecules starts to move away from each other. Their intermolecular forces are going to be weak as compared to the initial situation. So when materials are heated, they expand. Okay, Mariam, do you know about some basic knowledge about thermal physics? Because we are at the last topic of this chapter. So you joined today. So any basic idea about thermal physics or thermal properties?
Yes, sir, I have.
Okay. So if you have any confusion, you may ask, right?
Okay, sir.
Because all other are already studying with me, so they don't have any confusion and no gap in the topic. So they already know the things. So if you have any confusion or want to ask anything, you may ask, no issue.
Okay, sir.
So basically in generally we can say that when materials are heated, so they starts to expand, or in terms of molecules we can say that molecules starts to move away from each other. Away from each other. And we already discussed this concept in some past paper question. If you remember, last time we are doing some question in which there is a question related to the term that in terms of molecules explain how energy help us to break the bond, or like this concept. So we write that we use that energy to do work against the intermolecular forces or to break the bond between the molecules, right? So basically, thermal expansion actually helps you to break the bond between the molecules or to decrease or to just weak your intermolecular forces between the molecules of solid, liquid, or gases, right? And let's suppose if we compare this thermal expansion in solid, liquid, and gases. So when the temperature of solid, liquid, and gases will increase, so what do you think that which state of matter will expand more? Solid, liquid, or gas? If we compare three of them,
The gas. Yeah, gas would.
yes,
Because their molecular form is already very unstable. So
yes. So you all already know about it because gas can easily be compressed and easily be expand. So that's why the expansion in the gas will be the greatest among all states of matter. And the vibration of the solid molecules will increase as compared to the initial state, and liquids is in the middle of gas and solid. And if we compare the gas molecules, so they expands the most as compared to solid liquid states of matter. So basically solid will tends to expand the least. It means that they will not start expanding just like liquid or gases, but they are in the state that if we provide more thermal energy to that solid material, so they starts to expand, right? So they are in the state of tends to expand the least, right? And gases expands the most. And the final thing is liquids fall in between the two states, that is between solid and gases. Okay.
Sir,
And
I'm just writing them down.
okay, if you are writing during the class, it's up to you. Otherwise, you know that I will share the PDF file after the class. So you may just take the screenshot after we complete one slide. Okay, so that will also save your time.
Yeah, okay.
And if we talk about the molecular structure of solid, liquid, and gases, so you all know that why solid expands the least as compared to liquid and gases. If they ask you in the paper that why solid expands least as compared to gases and liquid, so explain in terms of molecule. Any idea how to explain?
So can you repeat?
Basically, if they ask a question in your exam that why solid expands least as compared to liquid and gases, can you explain in terms of molecule?
Because
Hmm?
solids have the greatest intermolecular forces,
Yes,
and so they require a lot of energy to expand and break those bonds.
They have the least kinetic energy.
yes.
Oh yeah,
So due to a strong bond, or you can say that due to strong intermolecular forces, right? In short, IMF, intermolecular forces. IMF also means something else, but we are using in physics for intermolecular forces, right? Because now you all know about intermolecular forces, so that's why we are writing short. But in exam, don't write IMF because IMF means something different. And if we talk about the gases, so they expand significantly. And you know the reason why they expand the most?
they have the weakest intermolecular forces.
Yes.
The weakest bonds in the
Yeah.
most scale.
Yes, or you can say that there will be no bonding between the molecules or the weak intramolecular forces as compared to the other two states. And the final thing is related to the liquid. So it will expand more than solid. And you already know the reason, because they have weak intermolecular forces as compared to the solids. Okay, so this is the basic scenario. You can see that between the solid, liquid, and gases, and there is a specific concept related to the solid in your syllabus. Because in liquid and gases, we know that if we supply thermal energy or heat energy to the body, so they starts to change their state very quickly, right? Not like the solid, because if you supply thermal energy or heat energy to a metal rod, so you know that it will take very high temperature to completely melt, right? Otherwise it will not change its state, just like liquid and gases. So if we first consider the concept of the solid in our daily life, so if you observe these diagrams in your daily life, like the first one, this one, and the second one, so in your daily life experiment, ever you observe that why there is a gap between the railway tracks or between the two track rod on the railway, and why there is a gap between, you can say that between the two pieces of the flyover, or between the connection of the two roads, or like something on your normal road streets or on any flyover. So you observe that there is a gap between the metal bodies like this. Like in railway track, you can see that there is a complete clear gap between these two pieces, right? And you can also see there is also a gap between these two metal pieces, right? So why there is a gap between these two metal bodies or metal pieces? Any idea?
So they're in the heat when they expand. So like they,
Overlap each other.
yeah, so there's a big gap
Yes.
already.
Because you know that if we consider the summer season, so you know that temperature is already very high, and we already know that the thermal heat capacity of solid is very short as compared to liquid and gases. So it quickly starts to gain the heat, and the temperature of the metal body starts to increase very quickly, right? So that's why there is a gap between the metal bodies or between the metal pieces. Because if there will be no gap between these metal pieces, so they starts to overlap each other, and that will derail your train track or any other vehicle that is moving on that surface, right? So that's why there is a gap between these two pieces. Because if you suppose that these two pieces are in contact with each other, and there is very high temperature like 35 to 40 degrees Celsius, and when the wheel of that train starts to slide over it, so you know that due to friction, because train moves with very high speed, and it also have that metal wheels, so when they slide over each other, so there is very high friction, and friction will also produce very high amount of thermal energy. So that will double or just 3 times increase the thermal energy on that metal piece. So definitely they will starts to expand. And when they starts to expand, and if there is no gap between those metal piece, so they will starts to overlap each other. So due to that reason, there is a gap between these metal railway tracks or any other metal pieces, right? Clear?
Yes, sir.
So this is the normal daily life scientific reason that why there is a gap between the metal bodies in our daily life when we use in different structure. And also we use this expansion of solid in different examples, just like there is a concept of bimetallic strip. Okay, one more important thing. If you just check out your syllabus, I just shared the syllabus update with you. So in that I mentioned that how much topics we already covered. But if you take a reference from the thermal physics section, so let me show you again. Yes, this is the of thermal expansion we are talking about. So these are two topics we have to discuss. Describe qualitatively the thermal expansion of solid, liquid, and gases at constant pressure. Describe some of everyday application and consequences of thermal expansion. And further, third point is related to the arrangement of the molecules. Because in old syllabus, there is a concept of relay, there is a concept of bimetallic strip that to study about their diagram, to study about their structure. But in your new syllabus update, there is no concept like that. Okay. So we are only talking about these things just for the reference, just for the example, right? So you are able to know that how these things we can use in our daily life, because there is a concept of application in our daily life. Okay. Otherwise, you can see there is no such concept related to or specifically mentioned in your syllabus that study about bimetallic strip or study about relay or different mechanism based on thermal expansion. Okay. And this is the third chapter, transfer of thermal energy. Okay, because in old books or in old syllabus and in old papers, you find the questions related to that. So don't get confused that are these topics included or not. So these topics were excluded in May June 23. So we only talking about these examples just for the daily life example. Okay.
Okay.
So basically we are talking about the solid, and there is a concept of bimetallic strip. Why it is called bimetallic? What is the meaning of bi?
Two.
Yes.
Yeah, means two.
So bi means two. So basically we are going to use two different metal pieces, just like in this diagram. This is the first one. This is the second one. And in bimetallic strip, if we consider only the scientific reason that why we are using two rods or why we are using two strips. So in bimetallic strip, there are two different metals, right? Two different metals in the sense that they have different specific heat capacity, right? And you all know about the specific heat capacity concept. It means that one metal quickly just absorb the heat and increase the temperature as compared to the second piece of metal, right? As you can see, if we consider in the diagram again, so you can see this is the red one. It means the first one, and this is the second one. So according to this situation, in the first diagram, so what would you suggest that which rod actually expands or which rod actually compress in the first diagram? If you want to explain this diagram, so what do you think that how you are going to explain this diagram? Any idea? The red one expands more or the blue one expands the more? Because both metals have different heat capacity, so that's why they are just expanding. One is expanding or one is like expanding less as compared to the second one. So red one is
The I guess, not sure.
okay. If anybody wants to explain, you may explain.
Wait, so can you repeat the question? Sorry.
Okay. So you are having two rods, right? One is the
All
red
right.
rod, okay, that is made up from different metal, and second one is the blue that is made up from different metal. So if you just take the example from the first figure, this one, so what do you think that which metal expands more?
Basically,
Hmm.
the top layer,
Hmm.
doesn't expand. It's like stays the same shape, and then the
Okay.
bottom one expands, which causes that type of curve. This is a bimetal strip, right?
Yes. So this is bimetallic strip basically. And according to the shape in the first diagram, so you want to write the comments for this diagram, so you may comment like this, that the blue one expands the more and the red one expands less. Because if blue expands the more, right, so definitely the size and the distance, or you can say that the distance between the molecule expands more for the blue metal strip as compared to the red one. Okay, so if we consider the blue one, so blue metal rod expands more and the red one expands less,
Yeah.
right? Any confusion? So basically, when we provide a thermal energy to the metal strips, so you observe that the blue one expands the more, but red one expands the less. And if you compare with the second diagram, so again, if you compare these two metallic strips, so what do you think?
So the the red one expands more and then the blue one
Hmm.
expands less.
Yes. So in
Or the blue
second,
one cools more and the red
yes,
one cools less. Like that.
yes, that is the second point that I want to explain over here, because there are two different ways to explain this concept. The first one we explains in the terms of expansion, and the second one, as you mentioned, like the contraction over there. So blue actually contracts more as compared to the red one, which contracts less. Okay, so the blue rod actually contracts more as compared to the red one, which contracts less. Clear? Any confusion? And we use this concept in our daily life. As you can see, we use this concept of bimetallic strip. Basically, this is the old concept, because nowadays we are working on electromagnetism. We are not working on the thermal energy concept anymore, because we are having advanced technology. So that's why we are working on electromagnetic theory. We will also discuss that thing in electromagnetism. But still, if you want to study about the old mechanism, so we use bimetallic strip for like the alarm system, or to make the connection, or you can also use this one as a switch or as a trigger, right? You can see there is a gap between the contact and the bimetallic strip, but when there is a high temperature, so this bimetallic strip attracts towards the contact rod because of the expansion or because of the contraction, and that completes the circuit. Okay, so that is the thing we use in different mechanism. Still, if you want to make the mechanism with the help of a bimetallic strip, so you can also make the mechanism using bimetallic strip, right? It's up to you. Okay, any confusion in any concept?
No, sir.
Okay, so
No.
No.
yes, because we are using this concept in daily life for solids very much. And secondly, if you talk about the liquids, right? So the example of liquid is like the thermometers, right? Actually, thermometer is also included in your old syllabus, but now that is also removed. So we are not going to discuss that concept, but just for the daily life application. So if you want to study about the expansion in the liquids, so any example that helps you to explain the concept of expansion in liquids? Any example of daily life?
Of what?
if you are talking about the expansion in liquid, right? So any daily life example that gives you the idea of the expansion in liquids.
No, I don't have any.
Very common example. Try to think about it.
The sewers.
What?
The
The sewers.
sewage. The sewage. Oh, because it's there. Oh, never
The
mind.
drainage system, basically, underground.
Okay.
Yeah. Technically, it's like dirty water.
How does that work?
Okay.
A gap is there, isn't it?
Okay. If you use a very basic example in your daily life that everybody observes, that is the example of the thermometer, right?
Right.
Because in thermometer, when the temperature of the body is very high, right? So definitely that will expands the liquid in the glass rod, right? Sorry, that thermometer. So actually when the temperature of your body is very hot, so definitely that provides thermal energy to the liquid, and that thermal energy actually expands the liquid molecules, and in thermometer the level of the liquid actually rises. Okay. Okay, any confusion?
No.
So basically, in liquid, we are having an example of thermometers, and for gases, we already discussed in the pressure and Boyle's law that how gas expands, how they react with the concept of pressure and temperature, right? Okay, one more topic included in your syllabus is related to the change of state. We already know about the change of states. We already discussed in the start, but you know that we have to discuss about the graphical representation, right? And the graphical representation means if you consider this diagram, so basically the change in state you can see if you starts from solid. So one process is mentioned over here, and in that process you can see there is a concept of melting. If you want to change your state from solid to liquid, so there is a process named as the melting, right? And if you reverse this process, so that liquid converts into the solid with the reference of freezing, right? And further, if you want to talk about the change of state from liquid to gases, so that is the concept of boiling. And if you reverse that process, so that is known as condensing. Because previously in your syllabus these all things are included in very detail, but you know you already studied this concept in your chemistry, so that's why they excluded those concepts from your syllabus, right? So that's why we are not talking about these things in very detail, but yes, they will ask you about the graphical representation. So we are going to discuss about their graphical representation, that how to draw the graph for different uh, change of states of matter. Okay. So let's suppose if we want to draw the graph, if you start from the solid, then we convert into liquid, then gas. So if we consider graphical representation on right hand side, or you can see that on y-axis and x-axis, okay, which quantity we have to plot on x-axis, time or temperature?
X-axis, time.
Yes.
time, right?
Yes. So
So that's the
let's
independent
suppose.
variable.
Hmm. Okay, Aksa, I think you got the link late, so that's why you are not able to join at the start of the class. Basically, we are talking about the change in state. That is the topic from thermal physics, right? Okay. So if you consider time on the x-axis and the temperature on y-axis, so let's suppose if you start from solid, right? So definitely when we start from solid, so we know that the temperature of the body is not equals to zero, right? If we start from the room temperature, so start from the room temperature, let's suppose we started from this point. This is the initial temperature of the body, okay? And when you are going to increase your temperature with the reference of time, okay, so the body is actually getting equal amount of thermal energy in equal interval of time, okay? So your graph will be a straight line like this with constant gradient, okay? And at this moment we are having a solid state, okay? And what happens next? Let's suppose if you take the example of ice cube. If you take the ice cube and you placed on the table, right?
Horizontal line.
Yes. So basically, when you take the ice cube and place on the table, so after some time, that ice cube turns into the liquid and there is a process of melting, right? And during the melting process, you know that there will be a horizontal straight line. Why there is a straight line? Because you know when.
Heat energy is used to overcome the forces of attraction between the molecules.
Yes, because when the change is actually going to state is going to be changed from solid to liquid, so your thermal energy is actually utilized in changing the state, right? So that's why this process will be known as the melting process. And when that ice cube melts, so it completely converts into the liquid, okay? So again, liquid will stay at their temperature for some time. And if we again start to provide some thermal energy to that liquid, so that liquid gains some thermal energy. So this state shows you,
Solid to liquid. Oh,
yes,
no, that's just liquid. Yeah, sorry.
liquid state, right? And if
Yeah,
you
yeah, sorry.
start providing, continuously providing the thermal energy, so that liquid starts to convert into
A gas.
gaseous state. But before that, which action takes place?
Horizontal line.
Yes, and that horizontal line shows you which process: melting, freezing, boiling. Which one?
Boiling,
Boiling.
and then there's gas.
Yes, because you know that water boils at 100 degrees Celsius. So air for short time interval, that liquid will remains at 100 degrees Celsius. And after that 100 degrees Celsius, your liquid starts to convert into gaseous state.
So how do you draw a graph for sublimation and deposition?
Okay, if you want to draw the graph for sublimation, so basically you have to show all the process, right? Because you are not going to draw the direct relation, because if you want to draw the direct relation, so from the first point to the last point you have to draw a resultant line, okay, that directly shows you that solids converts into uh, gases,
So
right?
just a straight line and no like horizontal line.
Yes, but before that,
Okay.
yes, because during that process there are different process also involved. So normally in your exams, they usually ask about that when we take the ice cube and it starts to convert into gaseous state. So draw and explain in terms of molecules how that reaction or how that process take place, right? So any confusion in this graphical representation?
No, sir.
No, sir.
Okay.
Wait, I'm just gonna draw it for my understanding. So.
Okay. So if you want to explain these things, so that is not much very difficult, right? And if you want to write some important point related to these process, so we can say that when a substance is changing state, so there are different states you can see, like solid to liquid, liquid to gas, melting, freezing, boiling. Different process are involved in this whole graph. So basically during that state change, we can explain in terms of molecules. The substance does not change temperature, and by this statement we are talking about this process, the melting, the right. So you can see in melting and boiling, there is no change in temperature take place, because there is a horizontal line that shows you that only the quantity of time is increasing, but there is no change in the temperature. Because you know that when you are going to change the state, so you need to do work to just break the bond and to just make the molecules away from each other. Because sometimes we got confused in the exam that how to draw the graphical representation, so we just take a variable line that this shows the change, but always remember that we require some energy to do work to just make them molecules away from each other to change the state, right? If we explain this concept in another point, so we can say that energy can be used to do work against intermolecular forces, intermolecular forces, or to break the bond. Okay. And all other details are mentioned in the notes. I already shared with you with the drive link. I will again share that link, right? So all points are mentioned over there, because you already know how this graph actually shows you the process, right? So I hope there will be no confusion in the graphical representation, right?
Yes, sir. Sir, you said intermolecular forces or intramolecular forces?
Intermolecular forces, internal
Oh,
forces between the molecules, right? And just one more thing, if they ask you about that to convert liquid into solid, so this graph will be in reverse direction, right?
yes.
So this graph will move in reverse direction if you are talking about the freezing process. And same happens with the condensation process that actually takes place between the gases to the liquid. All references are mentioned in the diagram. You can see condensation is actually from gases to solid. So this graph will also reverse at this point to show the condensation process, right? And there is another process involved. You can say that the vaporization, right? Because boiling and vaporization are two different concepts. Only there is a difference of a constant fixed temperature and at fixed uh, amount of heat that takes place. You already know about the difference we discussed in the last class. Okay. So any confusion in this concept related to the thermal expansion, related to the
No.
concept of the change in state? Because these are like now basic things you already studied many times these things in different uh, topics. And if we consider few questions related to the thermal physics, because now you study about the graphical representation.
Sir, when will we do chapter 11, 12 and stuff?
The thermal physics,
No, I guess that's waves. 11, 12, 13, 14.
basically that will take time in the sense because light will only take time. Otherwise sound chapter is very short. We can complete that chapter in 2 class. We can also complete electromagnetism in 1 class and the general properties in 2 classes, right? So around 5 classes will be enough for these 3 chapters. Only light will take time like 4 to 5 classes because that is a very detailed concept, because there is a ray diagram, there are numericals in that chapter, there are concept in that chapter, and that also includes in your alternate to practical paper ATP, because ray diagrams are very important in that chapter.
Okay.
Like if we talk, we are going to complete 80 to 90% in 1 month, right, of wave section. If we only
Okay.
talk about the topics, if we are not solving the questions with them, like only few questions, because we are also solving multiple questions related to that topics. Okay, if we consider question number 12. So in question number 12, they are asking describe two differences between boiling and evaporation, right? So you all already know about the differences, so we are not going to write that again. So these are the differences between the boiling and evaporation that we did in our last class. So you may write any 2 points, like if you are going to explain 1 point for boiling, so you have to explain that point for evaporation also, because question is for 4 mark. So point for boiling, then 1 point for evaporation, then second point for boiling, and second point for evaporation, right? So that will give you 4 mark. If you just only write that boiling will take place at fixed temperature and boiling uh, requires some source of heat, so that will only give you 2 mark. You need to also explain for evaporation process, right? Clear?
Yes, sir.
Yes, sir.
Okay, any confusion, Aksa and Mariam, because you are not in the last class?
No, sir.
Okay. And explain using ideas about molecule why thermal energy is needed to boil a liquid. That is the thing we are talking about in graphical representation. Anybody wants to answer this one?
Yeah, sure, I can.
Okay.
I don't know if it's correct, but okay. So
Mhm.
explain why thermal energy is liquid. So the increase in thermal energy causes an increase in kinetic energy, and then
Okay.
the increase in kinetic energy causes the particles in the molecules in a liquid to move
Mhm.
faster and
Okay.
expand.
Okay.
So these particles, these molecules then gain the energy to overcome the forces of attraction between them
Mhm.
and change their state into a gas and boil.
Okay. Good. Any other one wants to explain? Okay, so basically question is for 2 mark, right? So 1 point you all know that we require thermal energy to change the state from liquid to gas. Because when we are going to boil the water, so we are actually going to just reach at the maximum temperature of for liquid, then we are going to convert the state. But for 1 mark we have to write, because when you starts to boil the water, right? So at boiling point, uh, after the boiling point, liquid molecules are going to convert into gaseous state, right? So you required a continuous supply of thermal energy, because when high energy molecules starts to convert into the vapors, you know that not all the liquid molecules converts into the vapor at a same time, right? Like it happens like at 100 degrees celsius, after 100 degrees celsius all of your liquid converts into gas. It will not happen like this. They will start one by one. The top layer starts to convert into vapor first, then the second, third, fourth, fifth, like this. Okay. So basically we require thermal energy to break the bond or to overcome the intermolecular forces. Intermolecular forces plus we also requires thermal energy for the molecules that have low energy, because high energy molecules evaporate, right? Clear? Any confusion? So that's why we continuously need to supply the thermal energy to boil a liquid. Okay. And there is one more question, that is the numerical one. So there is a situation in one type of a bathroom shower, cold water passes through a metal pipe which contains an electric heater. So we are using electric heater to just increase the temperature, and cold water is passing through a metal pipe. You know that metal pipe conducts heat very quickly. So by the mean of electricity, we are going to increase the temperature of water. And the cold water is heated and emerges from the shower head. So the temperature of the cold water before heating is measured and the hot water, okay. And there is a total time of 1 minute. The whole experiment take place in 1 minute, and measurements and other data are, so the temperature of the water before heating is given. So this will be initial temperature T1. This will be your final temperature T2. And this will be the volume V, is the symbol for specific heat capacity.
C.
C. And density, you all know the
Raw.
symbol of rho, right? and calculate the mass of water leaving the shower in 1 second. So
Wait, so can you remind me of the formula again?
okay, I will write the formula. So the formula for specific heat capacity is C is equals to amount of heat divided by mass into change in temperature. This is the formula.
Sir, we don't have the power and
Mhm.
then
Okay.
the time. We don't have the power, but we have time.
Basically, the problem is we are having temperature, right? We are having okay, mass is missing actually. So that's why they are asking you about the mass. So can anybody answer that how to find out the mass? There is a hint in your question how to find out the mass. Hmm?
We
No,
have density
density,
and
can
then
we use the density and
volume.
volume, and we have density.
Yeah, yeah.
Very good. So basically, first we have to use the formula of density because now we already studied about these things. Density is equals to mass upon volume. So we are going to use this concept. Density is equals to mass upon volume. And from this, we can easily find out the mass. So density is 1000 multiplied by the volume, right? So we can just simply find out the value. What will be your final answer? Okay, let me also calculate the final answer. So 4.6 exponent minus 3 multiplied by 1000. 4.6, right? So what do you think your answer is correct or not?
Sir,
Or
they asked in 1 second. We took out for 1 minute.
that's the only thing you need to just check in your answer because they are asking for 1 second. In your question, the whole data is given for 1 minute. So we calculated this mass for 1 minute. So if we need to convert this mass to 1 second, so what we need to do? We have to divide by 60 because in 1 minute there are 60 seconds. So this is the total mass, or I will write over here 4.6 kg is the mass.
Sir, the answer is prepared in kilograms or grams, the final answer.
Kilograms, because all quantities are in SI. So that's why you have to write your answer in SI unit also. Okay.
Okay.
So 4.6 is for 1 minute. And if you want to find out for 1 second, so you need to divide your answer by 60. So if you divide your answer by 60, so that will be
0.077
0.077.
kilograms. Yes.
So that is the only thing in this question because they give you the data for 1 minute, but they are asking about 1 second. So we just use the formula, write the answer 4.6. We forgot this thing that they are asking about 1 second. So always put down your important quantities. And the second part, they are asking about the thermal energy. So now which formula will help you to find out the thermal energy?
The specific heat capacity one.
Specific heat capacity. So all quantities are already given in the question. Mass we calculated as 0.077 and we are using water. So specific heat capacity for water will be
4200.
4200. This is a constant value. If you want to again cross check, so 4200 and change in temperature 37 minus 16. So delta T actually means T2 minus T1. So what will be your final answer?
6,791.4.
Okay.
Is it joules?
Yes.
Okay.
So round off, you are getting this answer, right?
Yeah.
67,000 or 68,000?
No, wait, you have one extra zero. It's 6,791.
Okay.
Approximately 6,800.
6,791. Okay. So approximately it will be equals to 6,800, right?
Yes.
Uh, you all know about the formula of efficiency, how to calculate the efficiency?
Yeah,
Okay.
useful power output over total power input.
Your total multiplied by 100.
Yes. Akshay and
Yeah,
Marie,
percentage. Okay.
you know about the formula of efficiency?
No, sir.
Okay, so for efficiency, in simple words, if you want to calculate your percentage for your test or for your exam, so what we do actually, we just write down obtain marks in numerator divided by the total marks, multiply by 100. Okay, so that is also the concept of efficiency. So for efficiency, we can write like this: useful power or energy divided by the total power or energy multiply by 100. Okay.
100.
Yes. So it depends upon we are using power, energy, whatever we are using, it depends. So there is will be no confusion. So to calculate the efficiency of shower, the value in B part 2 and the value of one other quantity are needed. So basically we require two quantities as you can see in the formula. So one quantity is already given in your answer that you already calculated by yourself. Second quantity is missing. So which quantity is actually missing?
The useful amount of energy.
Okay, so basically calculate the thermal energy gained by the water. So this is the energy gained by the water. So what do you think? This will be output energy or input energy? Let's suppose in your class, someone is delivering the lecture just like in this class, and you are getting only one topic out of three. Okay, so your efficiency will be 1 divided by 3 multiplied by 100. Okay, so gain means the output, how much you gain from the source. So this will be your output or useful energy. Okay,
Oh,
clear?
okay.
Because what is the question? In question, you know that there is an electric heater. So this electric heater is actually providing the input energy.
Oh, and this is unknown. Acha.
Yes. So this is the concept. Okay. So basically your total energy or input energy is missing. And we calculated the output value. Okay. And describe how these two values are used to calculate the efficiency. So as we already note down the formula. So you just need to copy paste that again. Useful energy divided by the input energy,
If
or you can
we
also write, hmm,
if we write it in words, then also it's acceptable, right?
yes. because in this type of question they accept the both responses in the statement form or in the formula form, right? And this part is related to electricity, so you may just skip this part for the time being, right? We will discuss this concept in electricity section. Okay,
Okay.
so this is end of your second chapter of thermal physics, and now you are able to solve the questions related to the thermal physics, means thermal properties and kinetic property. Only one chapter is left out, that is related to how to transfer thermal energy in different ways, right? Conduction, convection, radiation. That is the most interesting chapter in this section. So we will start that chapter in the next class. Okay.
Okay, sir.
Any
Okay.
question, any confusion?